Hello everybody, and welcome to the next module of our CCNA training. Today we're going to talk a little bit about routing protocols, what they do, and why we need them. So first off, why do we need routing protocols? Well, static routes, obviously, as we've talked about, have a lot of overhead, and they have to be configured manually. You need to configure them on every single router that needs a route to a particular network, and they don't really account for link failure very easily. For example, if a link goes down, the static route will still point across perhaps the failed link, and the static route may not recognize when a link has failed. Every new network requires a new static route on all routers on the network, so this can be really time consuming. So basically, directly connected routes don't usually provide full connectivity in large networks. So our goal is going to be, instead of using static routes, to provide a way for routers to learn the different routes in the network. The best route should ideally reflect network performance, although that's not necessarily the case, and network performance can be described in a lot of different ways. So we'll see the different ways that routing protocols do that. Finally, we want to summarize several routes in a single route. This would be ideal because rather than having 5 or 6 routes to a group of networks, we could ideally summarize an entire group of networks as a single subnet. So we want to try to do that if we can. So there are several different distinctions in the type of routing protocols that we'll be discussing, and the first one I want to talk about is interior versus exterior routing protocols. Now, first we need to talk about the term autonomous system. An autonomous system is ideally basically a single organization, or the network under the control of a single organization. For example, AT&T might be considered a single autonomous system, or perhaps Cox, or maybe Wichita State. And so an interior gateway protocol is going to be used within a single autonomous system. So all of the protocols that we'll be discussing are IGPs. Now, there's also something called an exterior gateway protocol that's used to route between different autonomous systems. And the only exterior gateway protocol that we use today is Border Gateway Protocol, BGP. Now, that's not discussed on the CCNA, so I just wanted to mention it briefly here, but you don't need to know about BGP. Now, to visualize exterior routing protocols versus interior routing protocols, I've shown a couple different organizations here, and you can see their autonomous system numbers. Down there below, we have autonomous system 100 and 200, and you'll notice that within these two autonomous systems, we're using some sort of interior routing protocol, so RIP or IGRP. We won't be discussing IGRP, but we will be discussing its big brother, EIGRP. And now you'll notice between the two autonomous systems, we're going to use some form of exterior routing protocol, and today that would be BGP. Now, there are two different types of interior gateway routing protocols, and there are distance vector is the primary one. Now, distance vector, the router only knows the distance, and vector, that is the next hop to a given network. So now I say distance in hops here. Distance could be comprised of a lot of different components, and I'll talk about that here again at the end of the slide. Now, the idea here is that routing protocol, RIP, is the only distance vector protocol that we'll be discussing, and I say that with a bit of a hint in my voice of something to come. I'll talk to you about that here at the end. Link state protocols, on the other hand, are actually more comprehensive, and the idea with a link state protocol is that each router knows the state of every single link in the network. So all routers know about all interfaces and then decide to choose the best path based on the interface status. So OSPF is the only link state protocol that we'll be talking about. So in OSPF, every single router knows about every single link in the entire network, every single interface. And finally, we have a balanced hybrid, and I've called it enhanced distance vector, which is its probably truer name. And the idea here is that the router uses known topology from the neighbors, not all routers, and then picks the best path based on its neighboring router only. And so the neighbor is going to summarize everything past it, and this router will summarize to its neighbors in the same fashion. Now, EIGRP is going to be the one that we talk about that's an enhanced distance vector. Now, it's still, to me, a distance vector because you still only rely on a specific type of distance, and you still rely on the next hop, that is your neighbor. So EIGRP is technically a type of distance vector routing protocol, but for the Cisco purposes, it's also considered a balanced hybrid. Cisco likes to make their routing protocol sound all badass, so we'll leave it at that. Another distinction between the different types of routing protocols that I want to talk about is classful versus classless routing protocols. Now, classful routing protocols assume that every single classful network, every single major network is contiguous. So that means, what we mean by that is that all of the subnets of a network are behind a router that knows about the major network. So for example, let's say I have a router and I've configured on that router 10.1.0.0/16. That is a subnet of 10.0.0.0/8. And what this router classical routing protocols will assume is that if a router knows about one network that is the 10 network, it will know about all networks that are the 10 network. So the idea here is that if a router is configured with RIP that is next to this other router, it will assume that the router that knows about 10.1 also knows about 10.2 and 10.3 and so on. And in previous times, this was actually true. So they don't care about subnet mask information. They rely strictly on the information received about the major network, and they automatically summarize routes between major networks. So rather than saying that these subnets exist, they will say that this single major network exists. RIP version 1 is considered a classical routing protocol, and it's the only classical protocol we'll talk about. Now, classical routing protocols can cause a lot of problems, and so most of the routing protocols that we discuss are actually classless routing protocols. Now, classless routing protocols allow for fine-grained subnetting because they transmit subnet mask information. And now, the only classical routing protocols will support VLSM. So if you want to do VLSM on your network, you need to have a classical routing protocol in place if you wanted to do a routing protocol at all. Now, the only classical routing protocols will allow manual summarization. So with like RIP version 1, for example, we can't do any sort of manual summarization. We have to rely on classical boundaries. Now, most classless routing protocols will not automatically summarize between major networks. The one exception to this is in some certain circumstances, EIGRP will behave this way. And again, we'll talk about that. We may talk about that when we get to EIGRP. Now, RIP version 2, OSPF, and EIGRP, which are the major routing protocols we discuss, are all classless routing protocols, so you shouldn't have to worry about route summarization or crazy stuff like that. So here I wanted to talk about the concept of administrative distance. Now, this is determined by the routing protocol or the administrator. So for example, you see here the table of all of the different routing protocols' administrative distances, the route type down there in the center, and then the final administrative distance over on the right. Now, I want you to know that the more trusted routing protocols, the more high-level routing protocols, for example, you see BGP there has an admin distance of only 20, whereas, RIP has an admin distance of 120, which is much higher. Now, routers will prefer the lowest administrative distance, so a directly connected route will take precedence over a static route, will take precedence over an EIGRP route, for example, and on and on and on. So the idea here is that this administrative distance can be used to prioritize when multiple routing protocols are running on a single router, and you may run into scenarios where that's the case. Now, we have to talk about a concept called metric, which is used in a lot of different routing protocols. Each routing protocol has its own way to determine the best path to a network, and I talked about this a little bit earlier. For some routing protocols, it involves bandwidth. For others, it just involves a single hop. For others, it can be a little bit more complicated than either of those two. And so, with RIP, it's hop count. With OSPF, we consider it as the sum of the inverse of bandwidth. So it's going to be, for example, with a higher bandwidth, you're going to have a lower number, a lower cost. With EIGRP, it's a combination of the minimum bandwidth on the link plus the total delay across all of the links that the EIGRP has traversed. So each metric has its own advantages and disadvantages. Some are a little bit more accurate than others. Some tend to be a little bit easier to configure than others. But these are the different ways that different routing protocols represent a distance on a network. Now, here's a big summary of all the different routing protocols that we're going to be talking about. RIP version 1 and RIP version 2, you'll see there are a lot of differences there. But overall, the convergence for RIP is very slow. It's a very simple routing protocol. We'll talk a little bit more about that here in a bit. And then we move on to the more complicated routing protocols, OSPF and EIGRP, which have a faster convergence time, sometimes at the cost of configuration. So there's a big summary. I encourage you to go back and look at this as you're studying these different routing protocols. And that's pretty much it. So I'll take you into the next presentation for this session. If you guys have any questions, feel free to leave questions or comments in the comment section below.